So this is same unit of work, but example 4. So 9.02 example 4. So it's saying sketch the linear functions below by first finding the x and y intercepts. I think I probably want to define that for you. So the x-intercept is the point at which, let's say we've got a line there, and this is the x-axis and this is the y-axis. X is always horizontal, y is always vertical. The point at which the line crosses the x-axis is what they call the x-intercept. And the point at which the line crosses the y-axis is called the y-intercept. And they have special features. One is that the point, what's the y value? Let's see if you guys can see it from the graph. What's the y value where the line crosses the x-axis? Well, the y value is 0. So where x equals whatever that is, we don't know what it is, but we know for sure that the y value is 0. What about the x value where the line crosses the y-axis? So we don't know what value that is, but we certainly know that at that point, x equals 0. Okay, so you can see there where it crosses the x-axis, y equals 0. Where it crosses the y-axis, x equals 0. So to find the x-intercept, we set y equals 0 in our equation. And to find the y-intercept, you set x to 0. If you wanted to do that up in a table, like we were working on before, where x is 0, you will have the y-intercept. Where y is 0, you will have the x-intercept. Okay, so let's practice that. How do we actually work it out? So the first one they've given us is y equals 2x minus 6. Y equals 2x minus 6. So let's first of all find the y-intercept by setting x to 0. So when x is 0, y equals 2 times 0 minus 6, which is 0 minus 6 is minus 6. So that's the y-intercept. And you noticed I sort of foreshadowed that when I did the exercise earlier. I always think finding the y-intercept is really easy. Nice, easy way to find a point on a line if you can. To find the x-intercept's a bit trickier. We've got to set y to 0. So when we set y to 0, we end up with 0 equals 2x minus 6.